Welcome to the notes for section 4.3. In section 4.3, we're going to be talking about discounts and markups. Let's read the definitions for these, and I'll try to explain a little bit more about what that means. A discount is a decrease. So this is your notes packet, section 4.3. Make sure that you're there. It's immediately after the section 4.2 practice A. If your notes are still in the correct order, it should be easy for you to find it. So a discount is a decrease in the original price of an item. Okay, so the easy way to think of a discount is when you go shopping and you see they've marked maybe your favorite sweater down by 25%. That's an example of a discount. To make a profit, stores charge more than what they pay. The increase from what the store pays to the selling price is called a markup. Okay? So the stores have to charge more than they pay in order to just keep their business running. So that's what markup means. Now, for our purposes, feel free to think of a discount as a percent decrease, because we know how to calculate percent decrease. Markup is an example of percent increase. Okay, so if you think of it in terms of percent decrease, percent increase, then it should make some of our problems easier for you to work through. And we're going to look at 4.3 practice. This is again in your note packet. We're going to go through these. I'm not sure, we're probably going to have to do some of the work on a separate sheet of paper. So we'll make sure we get the answers on here. I'm not going to specifically say that you have to do it on a separate sheet of paper, but I have a feeling you're going to need to, because there really isn't a lot of space here. So I would encourage you to just take a moment now, get a clean sheet of notebook paper, and just put it in your binder immediately after this page. And then label this 4.3 practice. Let's call it practice notes, because practice A is going to be your assignment. So these are practice notes. All right, so we're asked to complete this table. We've got an original price, a percent of discount, and a sale price. Okay, so we're going to use what we know about discount being percent decrease to help us solve this. So for number 1, we've got a percent decrease, and we know that percent decrease or percent discount is equal to original minus new divided by original. Same formula from section 4.2. So in number 1, we have a percent discount, a percent decrease of 20%. I'm going to go ahead and write that as a decimal, 0.2 equals. The original was given to us as $20. Minus, we don't have a value for the new. The sale price would be the new price, so we're going to have to call that X. And then we're going to divide by the original, which was the 20. On the calculator, I can cross multiply 20 times 0.2. That's going to give me 4. And when I cross multiply this way, then I would do the same thing this way. 1, so I did this to get 4. And now 1 times 20 minus x is going to give me 20 minus x. Definitely put this on a separate sheet of paper. Subtract 20 on both sides. 4 minus 20 is negative 16. And then you're left with negative x on the right. So you had negative 16 equals negative x. You need positive x. So you can multiply or divide both sides of this by negative 1. To get positive 16 equals x. So the sale price is $16 for number 1. Number 2. We're still working with percent decrease. We're going to start with that same formula, percent decrease. So write it down, equals original minus new all over original. So if Miss Lewis is taking the time to write this in the video, then you are taking time to write this in your notes. So percent decrease, this time we have a percent discount of 35%, so we're going to put that in as 0.35 equals. The original price for number 2 was $95. We're solving for the new price, X, and we're dividing it by the original, which is 95. Again, we're going to think of this as being over 1, so we can cross multiply. 0.35 times 95. That gives us 33.25. And 1 times 95 minus X is 95 minus X. Now we need to subtract 95 on both sides. So 33.25 minus 95 gives us negative 61.75 equal negative X. And just like in the last one, we're going to divide both sides by negative 1, and that'll give us positive 61.75 equal X. So that means that our sale price was $61.75. So that's the first 2 pages. That's what yours should look like. Number 3. This time we're given a percent discount and we're given of 75% and we're given a sale price of $55.50. We're still using our percent decrease formula. Percent decrease equals original minus new divided by original. So we need to substitute our percent discount was 0.75, so that can go here. The original, this time we don't know our original, so that's going to be our X. The new is the sale price. So make sure you're understanding that original is what the store paid for it. Sale price is what the store sells the item for. So the sale price is going to be the new value in these problems. 55.5 over the original, which is X. So you can put your 0.75 over 1, and you can cross multiply. 0.75x equals 1 times x minus 55.5. All right, we have to get all the x's together on the same side, so the easiest way to do that would be to subtract this x on both sides. 0.75 minus 1 is going to be negative 0.25x. Equals negative 55.5. Okay, so I hope it's clear that when you see negative x, that's understood to mean negative 1x. So that's why I did 0.75 minus 1 to give me negative 0.25x. Now to get x by itself, we divide both sides by negative 0.25. Okay, so the negative 0.25 cancels. We're left with x equal, and the calculator will help us. We'll type in negative 55.5 divided by negative 0.25. And that gives me 222. So the original price for this thing was $222, and that will go in this box. All right, so what you're really, the new part here, I think, is just learning how to do the algebra steps, because it's still, you're doing percent increase, percent decrease like you did before, but you've got a little bit more work to do in solving each equation. Let's look at number 4. We know that percent decrease or percent discount equals original minus new over original. In this problem, we have a percent discount of 40%, so we'll put 0.4. Original, we don't know, so that's going to be x. Our sale price is the new value, so 78. Divide by the original, which is x. Now we can cross multiply. 0.4 times x equals 1 times this is x minus 78. Divide both sides by, no, excuse me, no, don't divide. We have to get all of our x's together on the same side. So let's subtract x on the left and on the right. You could do minus 1x. 0.4 minus 1 is going to give you how much? Negative 0.6x equals negative 78. To get x by itself, we divide both sides by negative 0.6. Okay, so negative 0.6 cancels. We have x equals negative 78 divided by negative 0.6, 130. So that means the original price up here is $130. Okay, so that's how you would get that answer. So it's starting to look more like algebra. All right. Let's look at number 5. Find the cost to store, percent markup, or selling price. Now, notice this time it's percent markup. Percent markup we're going to treat like percent increase. Okay, so we're going to be using the formula for percent increase in numbers 5 through 7. So for percent increase or percent markup, our formula was new price minus original divided by original. How do you remember which way it goes? Well, if it's going up, the new value is bigger, so you start with that. If it's going down, the original is bigger, so you start with that one on the top. You always divide by the original. All right, so in this one, we've got a cost to store of $20. Okay, the cost to the store, is that the original or the new? Well, what the store pays is going to be the starting point. So that's the original. 20 goes in for the original. The selling price is the new price. That's the one that we don't know. So the original is going to be the $20 in the bottom. And then the percent increase is 15%, so 0.15. So we put 0.15 for the percent increase. The cost to the store was the original value here, so 20 went for original here and here. We have to solve for new. So we'll start by, we can cross multiply 0.15 times 20. Gives me 3. And then 1 times x minus 20 is x minus 20. And now I can add 20 to both sides. And that gives me 23 equals x. So that means our selling price is $23. So $23 is the answer to number 5. Number 6. Still percent markup. So you do percent increase equals new minus original over original. All right, in number 6, we're given a markup or percent increase of 80%, so we put 0.8. The new is the selling price, so 100.8 minus the original was the cost to the store. We don't know what that was, so that's x, and it goes in the denominator for original. We cross multiply 0.8 times x is 0.8x, and then 1 times this is 100.8 minus x. We get our x's on the same side, so add 1x to both sides. That's going to give us 1.8x equals 100.8, and then divide both sides by 1.8. So the 1.8's cancel. We have x equals how much? 100.8 divided by 1.8 is 56. So our answer is $56. Let's look at number 7. If you're doing percent markup, you're still doing your percent increase formula. Percent increase is going to be new minus original, divide by original. Okay, percent. So we've got cost to store is 110. That's going to go in for original. Selling price is 264. That's going to be new. We're actually solving for the percent increase this time, or the markup. So we're going to have 264 minus 110, all divided by 110. So this one is going to actually be easier to work through, because with it all being on the same side, this time you can just type it. You can. No. Let me go back. All right, so look at the top. 264 minus 110, how much is that? 264 minus 110 is 154. And then we divide by 110. That gives us 1.4. And we need to express this as a percent, so we're going to move our decimal 2 places, and that's going to give us, you can put the 0 in, it's going to give you 140%. Goes there. I do have a word of caution for you in a problem like this. When you see something like this, you've got 264 minus 110 all over 110. All right, watch what happens. If you type this directly into the calculator, if you're not careful, you've got to tell, your calculator does not understand order of operations. So if you type it in just like you see it, it's not going to do it right. It's going to mess up. So if you do 264 minus 110, and then you go straight to divide by 110, it's going to be wrong. It's giving me a number of 263, and that's not right. The reason is because it divided before it subtracted. So it didn't divide 110 into 264 at all. So what you need to do when you type something like this in, you need to make sure you say 264 minus 110 in a separate step, and then press equals, and then write that number down. And then you go to another step. Now you can divide that number by your 110 to get your answer. So just be really careful about that. All right, let's look at number 8. Number 8, a store buys an item for $10. To earn a profit of $25, what percent does the store need to mark up the item? Okay, so we're doing markup. That's percent increase. So we'll write down our formula. Percent increase is new minus original, divide by original. Okay, what can we do with that? They're going to buy the item for $10, so that would be the original price. So we can put that in. They want to earn a profit of $25. What do I do with profit of $25? What does that mean? Profit means that's how much money they're going to have left after they sell the item. So if they buy it for $10 and they need to have $25 left, what are they going to sell it for? They would have to, just think about that for a moment if you need to. But they're going to buy it for $10. After they sell it, they still need to have $25 profit. So that means they've got to sell it for $35. So their markup price is going to be $35. That's not the percent though. So that means for new, the sale price, our sale price is going to be $35. So you can make a note here if you want to. Sale price, this has to be $35. So that's what we need for our formula. And we have to solve for the percent markup or percent increase. So we're going to have the new, the $35, minus the original of 10, divided by the original 10. All right, you type it in. It's going to give you 35 minus 10 is 25 divided by 10. That gives me 2.5, because notice I divided by 10, so I just moved my decimal back one. Then I have to convert this to a percent, so I'm going to go multiply by 100. It's 250%. So my markup is 250%. Okay. Now, let me ask you a question. If you're taking notes and you're just writing this down, is that going to help you? If you need to go back and look at it to see how to do a problem, it's not going to be very helpful. If you have not been writing these down on a separate sheet of paper as we go back and start over and do it again so you have what you need. All right, let's go to number 9. This is going to be the last one. Number 9, your dinner at a restaurant costs $13.65 after you use a coupon for 25% discount. You leave a tip for $3. How much was your dinner before the discount? In part B, you tip your server based on the price before the discount. What percent tip did you leave? Round your answer to the nearest tenth of a percent. Okay, so it's easy for this to feel like information overload. They gave you a lot of information. We've got to take the time to just organize it and make sure we understand what's going on here. So what they're saying is your dinner was $13.65 after the coupon for the discount. Okay, you also leave a tip. Now part A, how much was the dinner before the discount? So before the discount would be like the original value. All right, if it's percent discount, then you need to be using percent decrease equation. So percent decrease starts with the original, because that's going to be the bigger one, and it subtracts the new. And it always divides by the original. So what is the percent decrease? Well, it's a 25% discount. So you could put 0.25 for percent decrease. They're asking us what was it before the discount. So that's original. That's what we have to figure out. So we're going to put X for original, and then after the discount it was $13.65. So that's going to go in for the new. And then divide by X. Okay, so how did I get all that? Where did it all come from? Percent decrease was the discount of 25%. The original is the amount that is the amount of the dinner before the discount of 25%. So that's why that's what we don't know. So X is going to go in for original. The price of the dinner after the discount is the $13.65, so that goes in for the new. So and I've used percent decrease because discount means percent decrease. And then I'm ready to solve, so I can cross multiply this time. 0.25 times X equals 1 times X minus 13.65. And then we're going to subtract X on both sides. And that's minus 1X, excuse me. Let me fix that. Minus 1X. Okay, so 0.25x minus 1x is going to be negative 0.75x equals negative 13.65. And then to get x by itself, I have to divide both sides by negative 0.75. And that leaves me with x equal this is going to come out to be a positive because I'm dividing two negatives. $18.2. So what does that mean in terms of the problem? What was the question asking us? How much was your dinner before the discount? Well, according to this, it was $18.20. It was $18.20. Part B, you tip your server based on the price before the discount. Okay, so that $3 tip is based on this price. What percent tip did you leave? Round your answer to the nearest tenth of a percent. Okay, so here you've got the tip and the dinner total, and we're trying to calculate a percent. So here you could think of 3 as a part and 1820 as a whole. So you would go to your formula A equals, so the part equals the percent times the whole. We're going to use that formula for part B. So I'm going to write down the part equals percent times whole. And I'm going to put in, for the part, that would be the $3 tip. The percent is what we're trying to calculate. And then the whole is the $18.20 that we paid for the food. Now, this is multiplication. You use your inverse operation, so you're going to divide both sides by the 1820. So 3 divided by 18.2 gives me 0.1648. I could go further, but I don't need to. And because the number after the 8 is a 3, then that means I don't need to round the 8 up. So I carried it out to 4 decimal places. Because it's a percent, the answer because they asked for a percent, they said round your answers to the nearest tenth of a percent. So this is not a percent yet. I've got to convert it, multiply it by 100, so it becomes 16.48%. And they want me to round to the nearest tenth, so there's my tenths place, and then the number beside it is bigger than 5, so it's going to go up to 5, 16.5%. And that is it. So those are the notes for section 4.3. You're going to be going through the practice A sheet in your packet. All right, so right here on this page, most of these problems are going to look very much like what we just did here. So you should be able to get at least through, I'd say, number 9 during class, as long as you took good notes and you can look back at these examples and you know how to proceed. Just make sure that you remember that percent discount is going to be the same thing as percent decrease. So you're going to use the formula for percent decrease for 1 through 6. That formula, again, percent decrease equals original minus new divided by original. If it says markup like these, you're going to do percent increase equals new minus original divided by original. So I think you can handle that part okay. The trickiest part is probably going to be doing the algebra to solve these equations. So get as far as you can with these, and I will should be back to talk with you about this material hopefully in next class. All right, thank you.